Welcome to this predicted paper from onmaths. This paper represents the best guess for the upcoming exams. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions and mini mocks. If you like what we do, please consider subscribing. So I'm going to start just by writing out the equation. And I could put my lines in. Okay, we're asked to make x the subject, so we're going to first of all add 10 to both sides. In fact, I'm just going to move all this over a little bit so I've got a bit more space. Okay, so we're left with m plus 10 on the left hand side, and we've got 1/7 x on the right hand side. Now to get rid of the 1/7, what I can do is just times both sides by 7. So 7 brackets m plus 10 equals x. So x therefore would equal 7 brackets m plus 10, but it says to expand your answer fully. So we're just going to expand the brackets, 7m plus 70. So this question says that Adrian, Ben and Charlie have some sweets, and the ratio of Adrian to Ben to Charlie is 9:6:13, but it also says that Charlie got 56 more sweets than Adrian, so there's 56 more sweets. Well, looking at the actual parts of the ratio, there are 4 more parts, so plus 4 parts, which represent plus 56 sweets. So the 4 extra parts are worth 56 sweets. So 4 parts are worth 56 sweets. So 1 part would be 56 divided by 4, which is 14 sweets. So all we need to do now is work out how many parts there are. Well, there are 9 plus 6 plus 13 parts, which is 28. And each part is worth 14 sweets. So the total number of sweets will be 28 times 14. So 28 times 14 is 392. So we know that James knows that he has a square. So we can actually get rid of all of this bit. It's not relevant at all to the question. And the question asks, what is the probability that the square is blue? Well, there are 3 blue squares, so it will be 3 over, and how many are there in total? Well, it says the total is 17. So the answer is 3 over 17. So for this question, we need to understand the different types of graphs from different functions. So if we have a reciprocal graph, it looks something like this, and like this. It could be the other way around, and it could be distorted, but it basically goes down to a point along here. It goes to infinity, and it goes to infinity along a point over here. And obviously those positions could change. Then we've got a linear graph. A linear graph is just any straight line, so just any kind of straight line, either up or down. And this doesn't look like either of those. Then we've got a exponential graph. An exponential graph just starts really small and then just really increases like that and just keeps going up. And here we kind of have that. Obviously the other way around, it starts going down, but here it's actually going up, so it can't be a reciprocal graph. So the graph that this is, or could be, is a quadratic graph because it's a nice U shape. So if we carry this on, it could be a nice U shape. It could also be a cubic graph as well. So it could go up and then down and then up, and that's a cubic graph. But the most obvious one is a quadratic graph. So quadratic function. So the symbol here basically means and the way I remember it is if you draw that symbol and just put a line through it, you can make the word and. So we're looking at the probability of getting something that is in A and C. So the only ones that are in A and C are this 8 and this 9 here. So we're going to just add the 8 and the 9 together, which give us 17. Now we need to then work out how many numbers there are in total, so that's all of them. So 4 plus 8 plus 9 plus 5 plus 8 plus 3 plus 11 plus 6. So we need the total, which is 54. And then we get the 17, and we put that over the amount in total, so over 54. The formula for the volume of a cylinder is pi r squared h, with h being the height. So we've got pi times the radius 11 squared times the height, and that gives us 7,602.654 blah blah blah, and to 2 decimal places that is 7,602.65. So to find our new triangle coordinates, what we're going to do is we're going to have a look and see what we have to do to get from the centre of enlargement to each of the corners of A, or the vertices of A. So to get from the centre of enlargement to this coordinate, we go left 2, but it says scale factor 3, so instead of going left 2, scale factor 3 would be 2 times 3, it's going to go left 6, so 2, 3, 4, 5, 6. So the new coordinate for our shape is going to be here. We're going to do the same to the other part, so up 2, 3, 4, and 4 times 3 is going to be 12, so 4, 5, 6, 7, 8, 9, 10, 11, 12, and then we've got to go left 2 to line it up with our coordinate here, and so we'll go left 6, so what, 2, 3, 4, 5, 6. So our new coordinates here. The bottom right one's just going to be a shared one, because it doesn't go anywhere. So we draw in our new shape, and there we go. And it says to label it B, so I'll put a B in it. So we know that the exterior angle is equal to 360 divided by the amount of sides, which we can just call n. And something you can do is actually just swap these two things around, and we can say that the n, the amount of sides, is 360 divided by the exterior angle for a regular polygon. So we just do 360 divided by 5, and that gives us 72. The word truncated means that we just literally cut off the next number along. So if we imagine this is our number, we just cut it off. So it's not the same as rounding. We just don't change this digit at all. We just cut off the remaining digits. So the smallest number it could be before it was cut off is 79.500000. The largest number it could have been, well, it could have been 79.5999, etc. So that's the largest it could have been. So to do our error interval, well, the smallest it could have been is 79.5, and it could have been 79.5, and we'll call this x. But we're looking at any number that is less than 79.6. So any number that's less than 79.6. If it was 79.6, then when we cut it off, it would show as 79.6. First thing we need to do is work out the volume of this prism, and it's a trapezium-based prism. So the volume will be the area of the cross-section, or area of the trapezium, times the length, how 3D the prism is. So trapezium is half a plus b h, and then times the length. Now A and B are the two parallel sides, which will be this one and this one, and then the h is the perpendicular line that hits both of them at 90 degrees, which is what perpendicular means, between the bases. So this will be the 25 meters here. So it's going to be half, and then we're going to add 1 and 5, times that by 25. The length is how 3D it is, so it would be that 10 there. So we're going to times that by 10, and that will give us 750. So it's 750 meters cubed. Now, there is a little formula we can make for the rate. So the rate of anything for this will be the volume gained over time. Now, with this question though, we're interested in the time it will take. It says how long will it take. So we're actually looking at the time. So it will be time equals the volume, which is 750, over the rate, which is 15. So 750 divided by 15 is 50. So it will take 50, and let's have a look. It says per minute. So it would be 50 minutes. So I'm just going to write this out again, just so we've got a bit more space. Okay, the way we solve this is very similar to solving an equation with equal signs, but this time we're going to do 2 tramlines because there's 3 sides of this inequality, and we need to get x on its own. So looking at the fact that we've got 3x plus or 3x minus 5, we're going to deal with that minus 5 first. So we're going to add 5 to all 3 sides. So add 5 here. So we'll just leave 3x in the middle and add 5 to the right hand side. Now we need to get rid of that 3, so we're going to divide by 3, and again we need to do it all 3 sides. So divide by 3 and divide by 3. So we've got x is greater than or equal to 7, and then we've got 10 is greater than x on the right hand side. So we're going to first of all find out how many potatoes were below 22 grams. So we're going to draw a line up at 22 and a line across, and that is 13. So there are 13 potatoes below 22 grams. And so to work out the probability of picking one below 22 grams, it's the amount that we have below that amount, or below that weight, over the total amount of potatoes, which will be 20. So it'd be 13 over 20, which is equal to 65 over 100, so that would be 65%. The first thing to notice is we actually have 2 radii here. So we've got this radius here and this radius here, and all radii are always equal in length. So we have an isosceles triangle here. So this angle here is going to be 19x as well, and we've got to write that down. So we're going to say angle OBA is equal to 19x, and the reason is it's an isosceles triangle. Okay, so we know these two are equal. Well, we also can work out x because, as I said before, we have a triangle here, and all angles in a triangle add up to 180. So we've got 7x plus 19x plus 19x equals 180 degrees. And this is angles in a triangle. Try and draw a better triangle, equal 180 degrees. Try and write out these reasons in full. Okay, so that's going to be, was it 45x equals 180, and let's get our solving lines in. And we're just going to divide both sides by 45. Okay, so we've got x equals 180 divided by 45, which is 4. Now, we're looking for this angle here. That's angle ABC. Now, there's a few different ways we could do this. We could work out what this angle is, because it's a big triangle, etc., etc. Or we can use the fact that we've got a tangent touching a radius. So we know that this, let's just pick a different colour, this angle here is 90 degrees. So we can write that down. So angle OBC equals 90 degrees, because it's the angle between a tangent and a radius. Again, make sure you write all the reasons in full. And so therefore, angle ABC, which is what we're asked for, is just 90 take away the 19x. Well, we know that 19x is 19 times 4, because we know that x is 4. And so that would be 76, so in total it would be 14 degrees. So angle ABC is 14 degrees. We're going to start by working out what outcomes will give us two different types of drink. So we could have OA or AO. We could have AW or WA. And we could have OW or WO. Now what we notice really when we do this is that OA gives us the same probability as AO, same with AW and WA, same with OW and WO. So we're going to just ignore the right hand side ones and we're just going to focus on the left hand side ones. To work out the probability of O and then A, so orange juice then apple juice, we work out the fact that it's 6 over, well, the probability of picking orange juice first of all is 6 over 27. And then if we picked an orange juice, the probability of picking an apple juice would be 9 over 26. And so that would be 54 over 702. Apple juice then water would be 9 over 27 and then 12 over 26, and so that would be 108 over 702, and then orange juice then water will be 6 over 27 and 12 over 26, and that would be 72 over 702. Now we're looking at the probability of this or this or this, and the word or means add. So the probability of OA or, I should put that in brackets, probability of OA or AW or OW is these added together. And when you add them together, you get 234 over 702. Now, I said we would deal with the reverse situations now. I'm going to deal with that now. And as I said, OA is going to be equal to AO, AW is equal to WA, and OW is equal to WO. So all we need to do to find the probability that the drinks are different is get the 234 over 702 and just double it. And we can do that by just doubling the numerator. So 468 over 702. That cancels down to 2/3. So there is a 2/3 chance that the drinks will be different. I'm going to first of all just focus on this rectangle here. And we know that to find the area of a rectangle, you multiply the two lengths. And when you've multiplied them for this rectangle, we get 697. But let's write down what A is equal to. And A will be equal to the area, which is 697, divided by the length at the top, which is x plus 30. Now let's focus on the other square, or the other rectangle. And this time we have A equal to the area of it, which is 1870, divided by the 10x. Now because both of these are equal to A, we can actually just get both of these fractions equal to each other. And what we can do is work out what x is going to be. So the first thing I'm going to do is I'm going to put my lines in because we are looking to solve. This is probably going to take a while. And I'm going to times both sides by the x plus 30, so I can get rid of the denominator on the left hand side. And so this will just be 697 on the left hand side because that gets rid of the denominator. and it would be 1870 times x plus 30, and then all of that over 10x. Same thing again, but I'm going to get rid of the denominator on the right hand side, so I'm going to times both sides by 10x. So we've got 697 times 10, which would be 6,970x, because it's 10x. And it won't actually do anything to the right hand side, but I'm going to expand the top, the numerator. It just gets rid of the denominator. So let's expand while I'm here. So that would be 1870x plus, was it 56,100? I believe that's right. Yep. Okay, so now we've got x's on both sides. So we look and see which one is the smaller amount of x, which is the 1870. And we're going to take that away from both sides. So take away 1870x from both sides. And that will leave 5100x on the left hand side. And then obviously we've got the 56,100 on the right hand side. And we want to get rid of the 5,100. So we're just going to divide both sides by 5,100. And so we've got x equals 11. So now we know x is 11, we can pick one of the equations that we had at the start, and I'm just going to pick the first one, and we can just feed in the value of x. So a equals 697 over, instead of x, it's going to be 11 plus 30. And when you do that, you get the answer of 17. So a is 17. So to find the shaded part of this diagram, we need to first of all work out the volume of the smaller cone, which is at the top, then work out the volume of the larger cone, which is the whole cone shown, and then take them away from each other. So the radius for the smaller cone is 4, and the height is 5. And the radius for the larger cone is 20, and the height is the 20 plus the 5, so it would be 25. So I'm just going to label them A and B. And so why don't we work out the volume for B first? And the formula for the volume of a cone is 1/3 pi r squared h, with h being the perpendicular height. So it's 1/3 times pi times 20 squared times 25, which is going to be 10,471.975, blah, blah, blah. We're going to work out the volume for A, and this time it will be 1/3 times pi times the radius now is 4, and the height is 5. So that will be 83.775, blah, blah, blah. So to work out the shaded bit, we're just going to do the volume for B, take away the volume for A. So it's going to be 10,471.975, take away 83.775. And all those I'm going to keep in the calculator to keep the accuracy. And that gives us 10,388.199, blah, blah, blah. And to 2 decimal places, it's going to be 10,388.20. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing.